Now we're gonna have a small recap about everything we just saw.
The first couple things we're going to talk about are about physical and chemical properties. To start with, we need to know what are properties. Properties are attributes, qualities, or characteristics of something. Properties are used to identify elements. Properties are the characteristics of a substance which distinguishes it from another substance. In chemistry, these properties are called physical properties and chemical properties. First, let's talk about physical properties. A physical property is a characteristic of a substance that can be observed or measured without changing the identity of the substance. Physical properties of matter include color, hardness, malleability, solubility, density, in between others. The next thing we're going to talk about is about chemical properties. Chemical properties of matter describe its potential to undergo some chemical change or reaction by virtue of its composition. Chemical properties include flammability, toxicity, acidity, reactivity, heat of combustion, in between others. And, as well as physical properties, we can see both in a daily basis.
Then we learned a bit about color. Color can define two things. It defines the groups on the periodic table. For example, only the nonmetals are going to be colored green, or maybe only the noble gases are going to be colored pink. But moving away from that, it can be a physical property because it doesn't change even when we take away some of the element. Let's use sodium as our example. The color of sodium is a very soft silvery white metal. But let's say we were to take a gram from the element. Just because we took that little gram doesn't mean that the element will change colors. So that is why it would be a physical property. Then we learned about the states of matter, which is also a physical property because an element can change from a liquid to a solid, but it doesn't change its chemical composition. The elements can change the property of matter depending on the temperature. For example, a lot of elements are solid at room temperature, and only 2 are liquid at room temperature. Also, elements that are gas have their energy levels completely filled. That is why you only see them at one side of the periodic table. Let's use mercury as a quick example. Mercury at room temperature is usually a metal liquid, but if we were to freeze it, then it turns into a solid. Now that we have that out of the way, let's move on to the next topic.
And then we have melting point, and melting point is the temperature at which a substance changes from a solid to a liquid. And melting point is a property of the element. It's pretty much the same, just that it differs within the periodic table because we have elements like helium which need very low temperatures for them to melt, or we have elements like gold which need very high temperatures for them to melt. Then we have boiling point, and boiling point is the temperature at which a substance changes from a liquid to a gas. And boiling point as a property of the element is the same as melting point. It differs within the periodic table. We have elements like nitrogen which need very low temperatures for them to boil, and elements like boron which need very, very high temperatures for them to boil. And then we have periodicity. Periodicity is the repeating pattern of chemical and physical properties of the elements, and it's one of the ways in which melting point and boiling point are arranged within their elements in the periodic table.
Then we learned about conductivity. We learned that conductivity isn't only about electricity, but that thermal conductivity also exists. Electrical conductivity being how good a substance is at transferring electricity. Then we learned about thermal conductivity, which is how good a substance is at transferring heat. The best thermal and electrical conductors are metals, and then the worst thermal and electrical conductors are the nonmetals. But those are good insulators. Insulators being the ones that can stop the conductivity. Lastly, we learned about magnetism, which we learned about 4 types of magnetism, being ferromagnetism, antiferromagnetism, diamagnetism, and paramagnetism. Diamagnetism and paramagnetism being the most common property in the periodic table. Paramagnetism is when objects are weakly attracted to a magnetic field. Diamagnetism when an object weakly repels to a magnetic field. Ferromagnetism is the strongest out of all the types of magnetism. It can be called a permanent magnet too, because even after taking away the magnetic field, the material stays magnetized. Lastly, antiferromagnetism, which is the anti-parallel alignment of the atomic magnetic moment, which make it act like a paramagnetic magnet. that is the end of our video. Thank you so much for all your attention.
Thank you.
Thank you!